Hello students, in this video we'll see an example of how to compute the value of an option over a time period longer than 1. So let's consider a stock tree. So I will start with $100 and go up to 110 or down to 90. And we'll say it goes up to 110 with probability 3/4 and down to 90 with probability 1/4. And then this will go up to 120 or down to 100 with the same probabilities, 3/4, 1/4, 3/4, and then down to 80 with probability 1/4. And say we'd like to buy the price of a call option with strike price 110. So what we'll do is we'll write down the terminal values. We'd like to find out the initial value of the call option. So we'll say this is going to be the initial value of the call option. We can find intermediate values of the call option on our tree. And we know the terminal value of the call option. The call option will be worth 10 over here. It'll be worth 0 in this case and 0 in this case. So I have my D1, D2, D3, then I'll have D4, D5, and D6. So what we'll do is we'll compute the risk-neutral probabilities and use those to discount. So for simplification, we will assume that the risk-free rate of return is 0. Meaning that if I put in $10 into a bond at time 0, it will remain $10 at time 1 and remain $10 at time 2. There's no continuous growth. We'll just assume this for simplicity of the calculation. So we will find our risk-neutral probabilities. So we want to find the risk-neutral probabilities at every juncture. So recall that the risk-neutral probability, P star, for one particular branch is given by S1 minus S2 over S3 minus S2, where I have omitted the factor. So typically, since we've assumed the risk-free rate of return is 0, there would ordinarily be a factor of e to the r delta t here. But since that we've assumed that it's 0, we will treat this term as if it was 1. So we look over here, and we see that for this first node, we will have the following. So our P star will be 110 minus 100 over 120 minus 110. So this will be 10 over, and the S2 is 100, over 20, and that will be a half. Similarly, we can see that in any of these other branches will also get probabilities of a half. So our risk-free tree will look like the following. We will have 100, 110, 90, 120, 100, 100, and 80. And for our risk-neutral probabilities, we'll have 1/2 at every juncture. Now, we can compute D2 and D3. So D3 will be the discounted expectation with respect to the risk-neutral probability, but our discounted expectation factor will be 1, since I'm assuming there's a rate of return of 0. And so we'll just have that D3 is 1/2 of D2 of D6, and D6 is 10, plus 1/2 of d5, which is 0. So we see that d3 is equal to 5. d2 will be 1/2 of 0 plus 1/2 of 0, and that will just be 0. So note here that this is my d6, this is my d5, this is my d5, and this is my d4. So we can now fill in these probabilities. Over here I will have a value of 5, over here I'll have a value of 0, and then we do the calculation one more time. So our d1 will be 1/2 times d3, which is 5, plus 1/2 times d2, which is 0. So our d1 will be 5/2. Again, this value over here is my d3. This is my d2. And we see working backwards in the tree that the value of our option at this time is 5/2. So our option is valued at 5/2. And that's the solution. Thank you very much.